An object is vibrating in the air. You gotta look out for those objects that are vibrating in the air. The variation with displacement x and the acceleration is shown below, right? So what's going on here is that they're just showing you that if something's in simple harmonic motion, there's some force, and it's a restoring force. So if you have an object of mass m, there's this force that's acting toward the equilibrium, and it's minus kx, right? And so our acceleration is just going to be force divided by mass, which is going to be minus kx over mass. So the acceleration is minus k over m. That's the slope of this line, right? Times x plus 0. So it's got a y-intercept of 0, et cetera, et cetera. Okay? That's what's going on here. So let's go to the questions. All right, the first thing says, explain two reasons why the graph opposite indicates that the object's executing simple harmonic motion, right? Talk about the force toward, or the acceleration, right? Toward equilibrium. And talk about how it's proportional to the displacement. Okay, if that's true, if that's the case, then it's simple harmonic motion. Okay, and then they say use data from the graph to show that the frequency of oscillations is 350 hertz. Okay, well this is acceleration. So how do we do that? If I know omega, I can tell you the frequency, right? Because there's a direct relationship. You just divide omega by 2 pi and you've got the frequency. So how do we figure out omega? I think we can do it using this. The absolute value of the acceleration is omega squared. And if this is the maximum acceleration, it happens at the maximum amplitude. So from this, you can read what the amplitude is. Notice that that's millimeters, right? Okay, so it's 0.6 x naught is 0.6 times 10 to the minus third meters, right? And then you can also read what the acceleration is, okay? Notice that that's 3,000 meters per second, right? Meters per second per second. This is just short of that, right? So read that off, right? You can read off also what that is. And you can solve for omega. And omega is quite large. It's between 2 and 3,000, right? Omega equals something, right? Well, that's radians per second. If you want cycles per second, you want to divide by 2 pi and you'll get cycles per second, okay? When I did that, I got just short of 350, okay? And remember to show them, when you do something like this, show them the answer unrounded and then rounded, because obviously the answer is given to you, so you can just write random stuff down and, they're on to that. I think that's it for this guy.